Hello everybody, today we're going to be continuing our discussion on glycolysis. In our last video, we went over what glycolysis consists of as well as some basics. So make sure to watch that before watching this, because today we are going to be going over some examples and review. The question reads, what molecule acts as an electron acceptor in glycolysis? The key term here is electron acceptor, because NAD+ is the electron acceptor, which is reduced. Therefore, this means if you read through all the options, we see that A is NAD+ is reduced to become NADH. So that would mean that A is the correct option. But let's go through the other options to see why A is correct. Now we know that NAD+ is reduced to become NADH. So when B says NADH is reduced to become NAD+, the opposite, that is incorrect. And C says NADH is oxidized to form NAD+. And while this is a process that can actually happen, this does not take place in glycolysis, so this is incorrect. Now for D, it says NAD+ accepts electrons to form NADPH. Now NAD+ does accept electrons, but it forms NADH and not NADPH. Now let's move on to the next question. In our next question, we're asked to find what molecules are formed by the end of glycolysis. Now the key word here is formed. It is not asking for the net gain of glycolysis, because if it was net, the answer would be 2 ATP, 2 pyruvate, and 2 NADH as shown here. So A is not the correct answer, because that is the net gain of glycolysis and not what was exactly formed during the process. Remember, though everything else stays the same, what is formed is 4 ATP. But because 2 is used in the investment phase, we say that the net gain is 2, while what was actually formed was 4 ATP. That means options C and D are the only remaining options to look at. But we also see that for D, they put 4 NADH instead of 2. So D is also incorrect, making C our correct answer. Now, let's review some of what we've learned. 6 carbon compounds of glucose ends up in 3 carbon pyruvate, and there are 2 pyruvate molecules because 6 can only be broken down into 2 groups of 3. This is G3P. And by the end of the process, there is the formation of pyruvate, ATP, and NADH. Now remember, this is the 10-step reaction for just one pyruvate molecule. This reaction twice will give us the net gain, which would be 2 ATP, 2 NADH, and 2 pyruvate. When we know what was actually formed was 4 ATP, 2 NADH, and 2 pyruvate. And that is it for our review session on glycolysis. Thank you so much for watching. Make sure to like and subscribe.